In today's lesson, we are looking at trigonometric identities. Now, there are a few identities that we must know. Now, why are these identities so important? Because they help us to simplify trigonometric expressions where we can't normally simplify or factorize them. Now, the first type of identities we're going to look at are compound angles. Now, compound angles are when we add two angles together or we subtract one angle from another, and they look like this. So the sine of theta plus beta, and as you can see, theta plus beta are two angles that we add together. Now, we could have used degrees as well, but for the simplification of knowing your identities, we're just using theta and beta. So we have sine theta plus beta, and we can write it as sine theta cosine beta plus cosine theta sine beta. Got it? And then we have the sine of theta minus beta. It's two compound angles because we're subtracting the beta from the theta. And we can rewrite it as sine theta cosine beta minus cosine theta sine beta. Then we have the cosine of two angles that we add together, and we can rewrite that as cosine theta cosine beta minus the sine theta and the sine beta. Now, as you can see here, we have a plus between these two compound angles, okay? And here in the written out part, we've got a minus between these two terms, okay? Got it? And the last one, we've got theta minus beta, which is also the cosine of these two angles, and we can write it as cosine theta cosine beta plus sine theta sine beta. And look, there is a minus and here is a plus. Very good. Now you need to memorize these. Then we also have double angles. Now, double angles are when we have two of the same angles that we add together. So for example, sine of 2 theta. So we've got theta plus theta, and we just write it as 2 theta. Okay, so this is called a double angle, and we can write it as 2 sine theta cosine theta. Got it? Then we also have the cosine of a double angle, and we can write it as cosine squared theta minus the sine squared theta. Then we can also write it as 2 cosine squared theta minus 1. And we can also write it as 1 minus 2 sine squared theta. Now later we will look at how and which one of these three different ones should we use to make our simplification easier. Okay, then we have the quotient identity. The quotient identity says that the tangent of an angle, in this case theta, can be written as the sine of that same angle, okay, sine theta, divided by cosine theta. Then lastly, we have the square identity, which is the sine squared theta plus cosine squared theta, and that is equal to 1. Now, this identity can be written in two other ways as well. When we take this term to the other side, it becomes this. Okay, got it? And also when we take the sine squared theta to the other side, it becomes this. Got it? So remember, this one can be written in three different ways. Now let's go and apply these identities. Now we're going to go and apply our identities. We are given sine 40 degrees plus 30 degrees, and we want to simplify it as far as possible. Now the first step is we have to identify that this is a sine compound angle. So we can write it as sine 40 degrees cosine 30 degrees plus cosine 40 degrees sine 30 degrees. I can also see that this as well as this is a special angle. So with special angles, we know that it is when we have a trigonometric function and the angles are either 30 degrees, 45 degrees, 60 degrees or 90 degrees, and we can simply type it into our calculator and already get the ratio of the sides. So we have sine 40 degrees, and this special angle becomes square root 3 over 2. We leave it in brackets because that was multiplication, and then this term becomes cosine 40 degrees, and the sine 30 degrees becomes a half. and then we just move this constant into the front of this term as well as this constant to the front of the term, and there is our final answer. Okay, excellent. Now let's look at another example. Minus sine 70 degrees cosine 20 degrees minus sine 20 degrees cosine 70 degrees. Now I can already see this is some kind of compound angle because we've got sine 70 and sine 20, cosine 20, cosine 70. But these minuses should not be there. So what I'm going to do is I'm simply going to take out a common minus, and then we've got sine 70 degrees cosine 20 degrees. This minus becomes a plus, and then I'm just going to take this cosine 70 and move it to the front of the sine 20 so that we have the right order as well. And there it is. Now what I can do is I simply leave the minus, and this I can rewrite as sine 70 degrees plus 20 degrees, which we can then again write as minus, and in brackets sine 90 degrees. This is a special angle, and this gives us a 1, and 1 times a minus is a minus 1. There we go. Now let's look at one last example. Now we are given 2 sine 15 degrees cosine 15 degrees. Now I can immediately see that this is a sine double angle that is written out. So I can take this and rewrite it as sine 2 times 15 degrees. That gives us sine 30 degrees, and this is a special angle, and the answer is a half. And there we go. So it's very important to know your identities and memorize them, as we are going to use them extensively later. See you again next time. Bye.